Here we have a problem on integration. That is, we have to evaluate this indefinite integral. Okay, let me start working on this. Okay, in my first step, what I'm going to do is I'm going to move this constant 9 out of the integration. Then I'm getting 9 times integral 1 over square root of. Okay, I'm writing this 81 as 9 square. Then I'm getting 9 square negative x positive 9 the whole square times dx. Okay, let me consider a formula in integration, that is integral 1 over square root of a square negative x square times dx. So it is equal to arc sine, let me write the stuff over here, x over a positive c. Okay, when I consider the integrand over here, it's almost in this form. At the place of a square, we have 9 square. At the place of x square, we have x positive 9 the whole square. Okay, if I want to use the formula I have explained over here, so here I need a single variable to be squared, that is like in the form just x square. But instead of a variable squared, we have an expression, it is squared. Okay, so for that, what we have to do is we have to substitute a new variable at the place of x positive 9. So that we'll have single variable squared over here, we'll be able to use the formula that we have discussed over here. Okay, now let me go with the u substitution, that is let u equals to x positive 9. Okay, since I have substituted a new variable u, I have to get this complete integration in terms of the new variable u. When I get the complete integration in terms of the new variable u, at the place of dx, I must have du. So for that, what do we have to do? So we have to find derivative on both sides over here. So that when I find derivative of this u, I'll be getting du. Since we have the original integration with respect to the variable x, we have to find derivative on both sides with respect to x. When I find derivative of this u with respect to x, I'm getting du over dx. On the right side, when I find derivative of this x, I'm just getting 1. Now let me multiply both sides by dx to solve for du in this one. When I do so, this dx will cancel out. I'm getting du equals to 1 times dx is dx. Okay, now let me continue with the integration over here. 9 times integral 1 over square root of 9 square negative, and for this x positive 9, I can substitute u. That's what I have done over here. So then I'm getting u square, and for dx I can substitute du, then I'm getting du. So now this integrand, that is 1 over square root of 9 square negative u square, is exactly in this form, that is 1 over square root of a square negative x square. So we can use the formula. So there is 9 times, the result of this integration is arc sine x over a, but at the place of x we have u, and at the place of a we have 9. So positive, the constant of integration has to be c as per the instruction given in the question. Actually, it is an indefinite integral. Whenever we evaluate indefinite integral, we must add the constant of integration. So the question says use c for constant of integration. So I have added the constant of integration over here. Okay, now 9 times arc sine. Let me write it over here. So u is a variable taken by us. It has to be replaced by the original stuff, that is x positive 9. So now we can plug in this x positive 9 for u over here. Then I'm getting x positive 9 over 9 a positive c. So this is the result of the given indefinite integral.